Yes, we are live now. Bhaskar, you can start.
Good evening, sir. Good evening to everyone present here. I hope everyone is safe and doing well. We are happy to invite you to join the live session on Reimagining Future of Work through AI and Automation by Mr. Sridhar Jonnala, Chief Data Scientist and Practice Leader in AI Analytics at IBM. Some of you might be familiar with him from his previous talk on AI and AI for Enterprise. Mr. Sridhar Jonnala has over 20 years of experience working in data science delivery and consulting, specializing in natural language processing, machine learning, and computer vision technologies. Currently, he is responsible for defining and executing AI technical strategy for IBM and establishing new age AI technology labs. As many of you already know, IBM was one of the pioneers in computer revolution along with Apple in the late 1970s. IBM is also famous for its Deep Blue project, which played chess against the then world champion Garry Kasparov in 1997 and turned out to be the first time a computer has ever beaten a world champion in a traditional match. IBM Watson, which Mr. Sridhar Jonnala was also a part of, is a question answering software based on NLP, which won a popular TV quiz show Jeopardy, competing against two of the all time champions in the show. Today, Mr. Sridhar Jonnala is here with us to explain how enterprises are moving towards a hybrid workforce using AI-powered digital workers to collaborate with humans to achieve a higher level of productivity in the companies. Over to Mr. Sridhar Jonnala.
Yeah, thank you very much, Bhaskar. Thank you for the kind introduction. Just give me a minute. I will share my screen. Are you able to see my screen?
Yes, sir.
Thank you. So, good evening, students. I think it's always a privilege to talk to you. Last year, we had a very introductory session on AI. And this year, we are going to talk on one lateral topic, which has gained a lot of traction in the market today. That's like the future of work in the organizations and the enterprises. So what we in IBM or in other companies, we are reimagining the work that the employees are going to do. It's going to fundamentally change. And then how it is going to change, it's not going to change on one single day. It's going to be changing in gradual fashion. And then today we are going to discuss about two things. What is like the AI, which has been thought about in the last 15 years, and then I think what is happening in the last 4 or 5 years, for what purpose? I think that's the essence of the session today. So let us get to the topic. Right? The fundamentally, if you really look at, we have been building models, a variety of models. It could be NLP models, predictive models, prescriptive models, and then post that what we have been doing is like we have been trying to put these AI models into production. So we are trying to see that how they can be moved to production in a faster manner. How do we can make these models leaner? How do I automate the data pipelines? How do I make these models safer? So these are the things that we have been working for the last 10 years for our organizations. But then in the last 4 or 5 years, there has also been a lot of focus on how do we perform innovation, or how do we bring innovation in AI in actually automating the applications. So we are actually moving away from models to the discussion on business applications using AI. So there's going to be two baskets of discussions today, because one is the model discussion, I think, which is very fundamental, that's going to remain. But also there is another dimension, which is that business applications and innovations in AI in the business automation side. Because business automation is what the business user sees. He sees the insights, he sees that how decisions can be made. It is the place where the humans and the AI models that we have created interact with each other in a seamless fashion. So that's where I think these two dimensions come into picture. So let me go to the next famous saying in our enterprises, right? So the tomorrow's advantage will go to those who design systems which can adjust to the people, not those that continue to expect people to adjust to the systems. So this is something applicable for AI very much. So we have to be designing AI which can adjust to the people, not the other way around. So this is the fundamental philosophy. And then I think it should be part of in every stage in the AI building and deployment. We can discuss about it in a little later. So let me also introduce you to this concept, right? The human-centered AI development process. So historically, if you really look at when I started 20 years before in the data science area in a bank, the primary discussion is about the statistics, the kind of statistics that models that we build, the how much is the accuracy, how much is the thresholds, all of those things. Those are the things that we always discuss. And then once your statistical parameters are fulfilled, then I think you think that the model is good, and then we move away. And then we go on to build the next stats model. Because that is at that time, we are not even called the data scientists. We are called like statistical models. That's how it is. Okay. So now I think that has changed. Now the concept is that you have humans and you have AI systems, and then they actually collaboratively work together. So here, if you really look at the human-centered approaches, that is the human behaviors, will shape the AI systems, and AI systems will in turn actually shape up the user experiences. And then the typical example is of your everyday device, the Apple device, the Apple iPhone that you use, where I think you use touchscreen technology, wireless data, human-centric design, use Siri, and all of those things that came into that, right? So it is like in collaborative fashion. As the user wants more, you try to bring in more. As the technology brings in more capabilities, those capabilities are rendered to the user for their improving their experience. So it's a two-way process that's getting in. So this does not just apply to one Apple iPhone, but it applies to every AI model that you are going to build. And when we are building these applications, right, when we are saying that the human is essential to building AI applications. But then I think there are also 5 or 6 focus areas which we might have to keep in mind when we are actually looking at building these applications, right? One is AI lifecycle. So today there has been a lot of the advancements there, where I think you are trying to automate the model building process. You're trying to automate the deployment process. You're trying to automate the data labeling process, whereas you have a lot of images, you want to know that whether it is a dog, cat, or you want to know whether it is a defect or a non-defect item. So all those data labeling activities are getting automated. And then, of course, the lifecycle orchestration, the entire process of sourcing the data from the data sources, building the data pipelines, modeling to deployment. So all of those things, there are orchestration layers which can actually connect to the different parts of the AI. So that is something which is getting matured. But what is also happening is like when we are trying to build this human-centered AI, we need to be building AI which can be trusted. That's most fundamental aspect of it. Because if you really look at an AI, especially in the key decision-making areas, suppose, for example, you want to approve a loan application. That loan application, just because your model has generated certain value, for example, you are using a deep learning model and it has generated lambda is equal to 0.5. You cannot reject an application just because a deep learning model has generated a lambda value equal to 0.5 or otherwise, right? So you need to have an explanation stating that because of this reason, your application is being rejected. Otherwise, the customer will not be happy or will actually can go against you in legally as well. So that explainability of the AI model is going to be very important for higher adoptions. The next thing which I want to also bring it out is like the trustness of the models, right? So for example, these days what happens is like you get a lot of data in the internet and then you try to use that data, and then I think the model can be built. It's not about just the sophistication of the model, it's also about the data you use, the data sampling methods that you use. There is equanimity or the equal representation of all the data samples that you're collecting. So all of those things, stressfulness, all of those things comes into picture, which is one of the also important factors that you need to bring in. And the other thing which I want to bring out, it is the neurosymbolic and language AI, which is like, as a human, right, you tend to make certain decisions based on generalistic thinking. And then there is your deep learning models, which are like pattern based. Now you cannot achieve just the human like decisions using just the deep learning models. That's where I think this new subject area, and then also we are trying to work with a few clients, is that what we call as a neurosymbolic AI, where we are trying to combine the historical symbolic decisions along with the some of the AI models or deep learning models, etc., so that the collective decision making is getting more effective. I will not get into more depth into that because that's a subject on its own, and we can have a separate discussion if possible in future. Then I think we are trying to build a lot on the conversational AI, where I think there's a dialogue between the user and the system, and then of course the process automations, which we'll think about it. So broadly, these are some of the focus areas that we are going to look at when you are building models. And then from the models, if you want to scale up to business automation applications, right? And then once we build this business automation applications, that is when your future of work is going to change. Okay, so let's also dig deep into the models, and then we come to the business automation, and then we also take some examples. The first step is like, let's look at the models, right? This is something which you would have seen in your curriculums all throughout, or you could have studied a lot of papers, research papers, etc. Right? The first step is like, you have the data from the data sources, you prepare the data sets. You have the models, you create and train. And then the third step you try to do is that you actually measure the models. So whether the model is performing accuracies, F1 scores, and all of those things. These are the three steps. Very well known. Nothing there to think about. Then if you really look at the AI life cycle, you have three steps: data preparation, modeling, operation. It's just an extension of the last slide. So for years, we have been focusing on data preparation. We don't have to talk about it. For years, we have been focusing on modeling. We don't have to talk about it. But what is gaining a lot of traction is this operations. That is, once your models are put into production or deployed into production, how do we monitor them? Whether they are performing to the required business needs, whether they are bringing the right level of automation, whether the purpose or intent for which it is being deployed is being served or not. And also, there is going to be a lot of change in this, in the data, the changes in the behaviors of the consumers or your end users. And then I think you need to continuously improve the models. So there is also been a lot of maturity in terms of how do we collect the end user feedback, the final users of the AI, and then how do I actually continuously improve it in retraining the models, etc. I think that's one of the things that is happening in the modeling area. And then also, if you really look at, not all the data that is coming from the users can be used for retraining. So there is a kind of a ranking from the users depending on the type of users, type of feedback that they give. I think that's one thing. There is a maturity happening. Then we are also looking at reinforcement learning at an enterprise level. The federated learning frameworks, I will just add upon that in the next slide. Then I think earlier, I think for the prediction, we used to use a lot of logistical regressions and linear regression models, time series models. But today, I think we are using even deep learning techniques for the predictions. And then most importantly, we are trying to adjust our AI models for the users in a more consumable fashion or in a more configurable fashion, whatever you call it as, that's what we do. And then I think data labeling has been traditionally been a very manual intensive exercise where we used to get a lot of ground truth, etc. But today we are looking at mechanisms. How do we generate that trained data or the truth data, etc. I think that's where I think you see a lot of improvements happening in this space. Okay, so this is about the AI life cycle, where I think still there is a lot of innovation, a lot of development, a lot of maturity has to happen. Okay. So with that, let me go to the next slide, where I want to just give you just a very, very tip of the iceberg snapshot of the what we call it as a federated learning, because this is gaining a lot of traction. When we say federated learning, what does that mean is like you have devices. Let's take the example of devices, mobile devices. You interact with the mobile devices and you generate a lot of data. So if you really look at 5 to 6 years, what was happening is everyone sends this data, goes to the cloud, and then there I think there will be one central model which will actually run against this data, and then it will generate the outputs. That's what was happening 5 years back. But then there are a lot of disadvantages to it, in the sense that you have to ship the data all the way from your device to the central cloud server or central server. And then I think there is always a latency factor and there's always a cost associated with it. Then the next phase came where I think the models that needs to be built and deployed on the cloud are shipped to the device itself, which means that on a tiny device, Raspberry Pi or a mobile device or any kind of an edge device, you have the model as well as the data. So data is getting generated at the device. There is a model which is getting run at the device, and then the insights are getting generated and consumed at the device level itself. There is no dependency on the cloud. So that's the next level of improvement. Again, we found one more disadvantages by this in the last 2 years, in the sense that this model, which is getting deployed at the device, it is getting to learn only that data from that data. It is not going to learn from the data generated from the other devices. So how do we overcome that? So that is where I think the federated learning came into picture. Google is investing a lot into this federated learning. IBM also investing a lot into this federated learning, where I think what we tend to do is like, I try to take the model, and then I try to, after it is being learned, I don't just transship the model, but I just transship the learnings from that model to the central model. And then similarly, all the devices where the models are getting run, they only ship the model parameters or whatever the delta parameters, whatever you call it as, to the central server. Now in the centrally, there will be a model which will actually run against all of these collected learnings from all of these thousands of devices. And then once it is run, then I think this model goes into all of those devices. So similarly, it is going to learn at each level, then ship it, and then the by this, what we are trying to avoid is like, we are not going to ship the entire model, which is costlier. We are not going to ship the data, but just the learnings. And then all the learnings are grouped together, aggregated. That's what you could see in the slide, what I have put, which is like the aggregation there. And then once it is aggregated, it is being distributed again to all the multiple devices. This is the latest approach that we are following today for the federated learning cases. Okay, now what we have touched upon is the models, right? We have also looked at like what are the various types of advancements that is happening there. Of course, we did not get into the deeper because that's not the intent of this session today. But let's see that, okay, a model has been created. What happens once it is deployed? So once it is deployed, what as a data scientist, what we think is like, okay, I need to monitor this model, whether it is working fine or not. So that's what I think any data scientist or any analytics professional would look at, any statistician would look at, whether it is doing fine, or it is accuracy is drifting, or etc. Right? Or they continue to validate the models. That's what it is. And then they collect the feedback, and then they try to improve the models. But what is important is like how it is impacting the application. That is more important, because you can improve the model accuracy, but if you can't improve the end business application, then it's a waste of time and money. That's more important, because many of the users, even for your iPhone, doesn't know what the model that is running at the background. What they would actually evaluate is like whether your applications that are running on your iPhone are good, bad, or whatever it is. Right? That's up. So it is not about the model accuracy that we are being evaluated in the business world or in the consumer world, but we are being evaluated for the business application performance. So that's what the core driving point that I want to drive out. Model is important, but business applications, business application outcomes are also important. This is what I want to drive to all of you today. The key element. Let me get to the next slide. Okay, so this slide, the focus always, or in the next 5 years, at least the roadmap that is given to us is automate the different elements of your AI lifecycle. As we talked about earlier, we saw in the chart data ingestion, model preparation, model deployment, model retraining, etc. So the objective is that the entire thing is going to be automated, which we call it as the AI on top of AI. So you have an AI process, and then we want to automate that AI process itself. Right? So that's what the thing is happening. Now, the second thing is like we talked about AI transparency and real-time governance of the AI models is something which is going to happen, etc. But what is going to happen, this being automated, what is that the work of the typical data scientist is going to be, a typical data scientist? That is where the business applications or business automation comes into picture. So the future of data scientists tomorrow is not just about knowing the models, knowing about the data alone, but more about understanding the domain, about understanding the use case, more about how do we apply these models effectively into these business applications is something which is going to be the real focus of the data scientist. Okay, so that's where I was trying to bring that difference. That is, there is a model and there is a business application. So and then how it is going to be more of like shifting towards the focus from the left to the right. So with that, let me go to the next slide. Right now, we talked about the topic of this agenda today is that how do we reimagine the future of work in the organizations. So when we say the future of work, we are looking at every process in the organization. It could be a lending process, that is a customer going to a bank and applying for a loan, or a student going to a college and applying for an admission, or it could be booking a tickets, right? So all of these things are happening today. But then the future of work could be like, today there are a lot of humans who are working on the other side, who are serving your request. So it could be in the university, a lot of people serving the request of the students coming in. It could be in a ticketing agency where there's a lot of call center people trying to address your queries, or in a banking where there's a lot of loan officers trying to approve our application. So the future of work tomorrow is going to be like human plus AI workers, what we call it as. We call it as the digital workers. I mean, people call by different names. Somebody call it as AI workers. But then it is going to be AI workers and humans who are going to be actually fulfilling all of the requests that are either coming from your customers or from the internal employees or kind of thing. So that's what is going to happen, which means that every process in your application, in your organization is going to shift. And then I think that shift is being driven by AI and automation. Now, once we actually look at business automation, right? So the automation, we come to the core topic of today, which is the business automation. What are the elements of this business automation? So first of all, we need to understand the process itself to automate that process. So today, taking the same example of loan lending process, somebody applies for a loan, it goes to the loan officer one, he looks at the application, tries to check the eligibility, then goes to his superior, the superior sanctioning officer looks at this application, sanctions the loan, or before that he sends it to the credit check to see that if the credit check is good or not, and then again comes back to him and then he approves the loan. All of those things. There's a process already defined. So now we need to understand whether that process that is already being established is doing fine or not. That is where I think you need to have a mechanism to understand how the process is working today, whether there are any backlogs there, whether there are bottlenecks there in that process, where I think your process you can find improvements in improving that process, etc. So that's where understanding and monitoring of the process is one of the things. The second thing that is more important is like your process cannot be fulfilled by just building certain models. You need to build models, AI models, but that AI models should be domain specific. If you are in a loan lending thing, you need to build a model which can predict the approve or reject the loan, and then that domain is the lending application domain. So you need to understand that domain. So the AI domain is going to be very important. And then if you really look at the process, it doesn't consist of one single straight flow. It consists of multiple flows and subflows that are involved there. So that is where you need a lot of flows to and fro and other things which we need a flexible composition and orchestration. I'll come to that little later. If you don't get it fully, that's okay. But at the end of the day, the crux of it is like, I would just want to summarize it by saying that we need to understand the process. We need to be building domain specific models, and it's going to be human plus AI worker who are going to fulfill your task. I think that's the summary of this slide. Let me go to the next slide where I can get into a little bit detail of that. Okay, so this will give you a little bit on what you're talking about. Right, the first thing is we need to understand the operations, which means that we need to understand the current business processes. So your business processes, it could be like you could want to book your tickets. You go on there, you want to give the timings of the flights. You will then say that from this date to this date, I'm going to stay there. Then you are going to book the hotels and other things. So there is, and then once all that is done, you submit your expenses for all the travel, etc. Now, these are the different kinds of steps. You would like to know that in the current process, where are your bottlenecks? Which process there are you take the maximum time, or at the back end maximum time to process your application. Okay, are there enough resources there, human resources there who are doing that task? Can I automate that process? So that is where the AI comes into picture, which can actually take all the logs from your business operations, and then it can understand the data and tell you where exactly your problem is. And of course, you can use any number of latent context, unsupervised pattern learnings, or any kind of modeling techniques that you can do. But at the end, the objective is that you will understand the bottlenecks in your current process using the process logs that are already collected from that process. Now, once you understand that process, right, then you can actually go and suggest some improvements in the process, and then those improvements can be implemented, and again you monitor, and that's a cycle that you go on following, right? So that's the first step that we call it as a business automation. You tend to understand the process, and then understand that what data is being used, try to understand how the drifts in the data is happening, etc. And then you try to bring in those bottlenecks out to the business users for them to fix it out. So with that, let me actually go to the next phase of the process automation. Just, I think, just focus on to me for the next 3-4 minutes, because there are 3 slides, and then all these 3 slides are going to be interrelated slides. So this is our concept, right? So you can think of these skills, right? There are multiple skills, and then a group of skills can form an agent. So a definition of a skill is an atomic reusable program or a reusable model. Okay, so a skill is a reusable program or a model. You can think of that, right? And then a group of skills can form an agent, and an agent executes a particular function. And who is this agent? This agent, we call it as a digital worker or an AI agent, whatever you name, you call it as. Okay. So the agents are going to be the important players in this. And then there are the orchestration layers, which means that you have different agents. You need to connect with these different agents. That's going to be more important. And then you have users who are going to be interacting with these agents to and fro through this orchestration layer. Okay. So that's what it is. Okay. So now let me expand on that concept. We have the different skills, which is atomic unit, And then you can think of different AI models as the skills catalog. You can think of natural language query, natural language generation, natural language understanding, your visualization, your dialoguing, and all of those things as skills. And then a particular group of skills can actually perform grouped into called an agent. And then that agent actually executes a particular business function. Okay? And this agent interacts with the human, and then it will actually generate a business insight. So far, I'm hopeful that you are with me. So I'm just trying to re-articulate that. So you have skills, which are like a set of models, set of AI services. And then I think a few of them are grouped together in a logical fashion, in a related fashion, and then we call it as agent. An agent accomplishes a business task, and this agent interacts with the human, and then it will actually seamlessly collect information from the human back, and then it tries to improve the underlying skills. Okay, so that's what it happens. This is just another way of representing the same earlier diagram, where the human actually interacts with this digital worker or with this AI agent, and through multiple channels, chats, emails, and all of those things. And then this intelligent agent actually can connect to multiple skills at the bottom: automation skills, productivity skills, AI models, etc. And then it tries to perform the action for them. Okay? So this is the crux of the business automation that we are trying to do. And if you have to expand it, how it is going to change the world, I will try to give you a few examples, right? So today, let's say that we are going to meet a person called Remy, a digital relationship manager, right? So what it does is, once you have put this system, this AI agents in AI agent system in place, or the digital workers is in place in your business, it will automatically try to tell you that when your intervention is required. Say, for example, today I'll just try to explain that today what the relationship manager does, and then in future, how does he operate. Today, the relationship managers of most banks, they have certain data. They just take it out from the data lakes or from reporting tools. And then they know that this customer has spent this much, and then I need to approach him for my investment. I can actually advise him for any kind of an investment, right? That's what it happens. So, but the user has to go to the tool, take the report, see it in the report, who has the maximum portfolio, call them, and does all the things, right? And then he or she has to decide what to sell for them and all of those things, which is time-consuming process. But tomorrow's world, the same relationship manager, by the use of this automation techniques and AI techniques, an alert will be sent, right? So, say for example, you would get an alert. A lead from the client. The client has asked, like, I need more information on particular investment. So he would actually put a request in the to the call center, or you could have sent a message, or you could have just left a chat. Now that relationship manager actually is being informed that there is a lead that has come up from this client asking about some investment clarification or whatever it is, right? And then this relationship manager, which we call it as Remy, can actually ask the system in a natural language fashion, like, what are the total investments that this client has already made with our bank earlier? Okay. Now that, okay, the system will come and tell, okay, this guy has already invested 2.3 million, and he has invested in these products. Okay. And then he will ask, like, can I have more information on the LinkedIn? All that you can either through the voice or through the typing, or you can ask the system. And then it will show that LinkedIn profile his role is a senior VP. He's working with this is company, etc. Right? And then it will again, the Remy, the relationship manager, asks the system, like, what are the products that are going to be sold? Then I think at the end of the day, you have a recommendation model which is running at the background, which will come and tell you these products are best suited for this candidate. And then the relationship manager again asks Remy, okay, fix an appointment, a calendar invite appointment with him. So automatically a calendar invite is sent to him, and an appointment is fixed with him. If you really look at the steps that is there, you are interacting with the system, and underlying there are multiple systems which are acting, multiple flows which are created, and all of this is happening in a seamless fashion for you, right? You are just interacting with one box or one system that is there. So that is what your future of work is going to be. So how this life has changed for this relationship manager, I think we are looking at different workers within the organizations, how their lives can be changed through the application of AI. Let me also take another example where we want to look at the ticket automation process. Right? If you really look at a travel operation process, there will be different people. I, as an employee, can actually raise a travel request. It will go to the manager, and the manager can approve or reject it. But if I actually ask for a business class ticket, and then it will go for a director's review, and then he may decide to approve or reject it. So there's a kind of a business flow. This is a typical business flow that you are looking at. Now, you can have digital workers at each of these places. So once the application is being request has been set, you can have the manager informed that such and such a request has come in the system. Okay, so the manager can actually initiate an alert request there, can initiate an alert request so that he will be informed whenever an employee raises a request, and his manager will be informed, right? So that's a alert skill that you can enable it. Then once you also enable a mechanism where I think you can actually, in a natural language way, interact with the system. So here is the employee who's trying to say that I want to go to this place and then I want to present the papers for this. So please approve this request. And then once he does that, the request goes to the manager who is being alerted, because we have already alerted the alert skill. And then this manager says, okay, whether I should approve it or not. So then I will go and ask, like, okay, how many papers he has presented and how many of them are Tier 1 conferences, how many of them have been approved. So all of this data in a dashboard fashion, it is going to come and pop on in front of him. Now the manager can take a decision whether to approve it or disapprove it. So this is how the work is going to happen, right? So you will have data-driven decisions, fact-based divisions that are going to happen, and this is going to happen on your channel of preference. So what the channel you see here is the Slack channel. It could be your Google channel. It could be your main iPhone, whatever it is, the channel that we want to use. All of the information can be consumed there. Okay. So in summary, what I would like to tell you is, like, there are two parts to it. The left-hand part is about data, model, operations, and building the business applications. But once you build those applications, you need to monitor them. You need to see that the intended purpose is served. And these applications have to work with the humans. That's where the human-centered design that we talked about earlier comes into picture. And then, of course, these models are to be infused with a lot of domain knowledge. Okay. So this is what, in summary, we want to look at. One is on the left-hand side, you could see that regular AI model lifecycle, and then going one step applications. On the right-hand side is about, like, once the models are put into place, once they are infused into business processes, what are the other things that we need to look into? And then what I earlier said, I'm restating, is that you need, in the next 5 years, there will be more focus on the right side of the path. So with that, let me go to two examples today, which I want to talk about, which are related to the business automation. Because business automation, business process automation, takes different shapes and forms in different organizations, or within an organization, within different business units. This is a leading pharma client. And then this client, when we were working with it, they came up with a peculiar problem. See, in the pharma industry, what was happening is that there is a lot of focus on health authority. There is a lot of focus on the manufacturing. There is a lot of focus on the regulations. Of course, you are coming with a new drug, a new medicine, and then you need to be focusing on all of them. There was a lot of focus on that. But what was not being focused is that the patient You can have a lot of regulations, but those regulations are really helping the patient. As the patient experience has changed over the years, or it has still remained the same. I think that is the kind of study that this organization has done. But I think overwhelmingly one outcome that has come up is like the patient experience has still not improved to a greater extent, especially on the drugs part of it. There are a lot of medicines that are coming into the market, and then but then the experience of the patients has not improved a lot. So okay, let me expand on that. If you really look at, there is labels that come with every drug, right? It could be your tablet, it could be your injection, or it could be any other procedure, whatever it is. And one thing we have found out is like most patients around the world, even in developed countries, there is a very poor health literacy. The knowledge is very, very less about the health literacy is very, very less. Okay. And then we also found that some countries, even that information is not being made mandatory to be shared with the consumers. So the product, the drug information, which means that the drug information itself is not shared. And then where it is shared, the health literacy is also not up to the mark, which means that whatever the information about the drug that are being published today have been least used by the patients. And because that the patients don't use this information, they try to break the drug, they try to use the drug in an inappropriate way. And then that is causing a lot of claims, a lot of life loss in certain cases. And then it's a lot of loss to the economy as well. Okay. So this is the fundamental problem. That is, the information of the drugs is not reaching in a consumable form to the users who don't have that much health literacy. So got the problem? Okay, let me go to the next slide. So just expanding on the problem. Today, most of these pharma companies, not just related to one pharma company, whenever they want to release the drug, they want to bring the drug to the market, they prepare something called as SMPC document, they call it as, which is like summary of product characteristics. When they say summary of product characteristics, it will tell you what are what is the name of the drug? I mean, what are the constituent of this drug? Who can use it, and how to consume it, and all of those things it will be done. But this document, it can be only be understood by the doctors, and then of course this document is directed towards the doctors. Okay, so this summary of product characteristics is something which was actually being directed towards the doctors and nurses, etc., for their consumption whenever a drug is released. So fair. Now, most of the companies, they also produce what we call it as the patient information leaflet, which is like, okay, I have this scientific leaflet which is directed towards the doctors, but I translate into a form that can be consumed by the patient. So they do this translation. But interestingly, what we have found is like there are nearly 20,000 people in the industry today. And these 20,000 people across the world, I'm talking about, their job is very simple thing. They look at the SMPC, which is the scientific information on the drug. They translate into PIL, which is the patient language, so that the patients can be easily consumed. 20,000 people are being employed for this very specific purpose to translate from scientific into consumer language. So, okay. So each of the pharma companies, some companies have 1,000 people, 1,800 people, kind of thing. Now, what we are looking at is like, how do we automate this entire thing, right? So, because what is happening is like, it is taking a lot of time to translate from SMPC to the PAL. And then because of that, some of the drugs are getting delayed for release into the market. Some of the life-saving drugs. So how do we actually reduce this time? Can we do some kind of an automation where you can convert that scientific language into a human consumable language. So that is the kind of an automation that we want to bring. So in that entire process, where I think we want to have a lot of thousands of people in the market who are taking a lot of time doing this routine task of translation, how can we do that? But this is not a simple problem, right? One thing is like when you're building such a system, you need to understand the medical language which is present in this scientific document. And then we need to be generating a language which is easily consumable. So you might know that as, I mean, since most of you are in the field of AI and analytics, you know that first is like, I need to understand the document, I need to extract the contents from the document, then I need to establish the context, then I need to generate, I'm going to use natural language querying, then I'm going to order it or sequence it in a form that can be used by the end users. So those are the multiple steps that if you're really looking at kind of thing, right? So this is what we were trying to do there. It looks very simple, but I think some of the times the simplistic approaches works better for solving the big complex business problems. So we went with 1, 2, 3, 4 steps, right? So we will use rules. Okay. So we will try to use that, how the output of the document should look like, right? So for that, we don't require any predictive model or whatever. So you need to have that kind of an template. You need to know that where each section of the document should be there. So that's the first step that we did. The second step, what we tried to do was, we tried to map the medical terms. We collect a lot of medical dictionaries and I mean, pharma's disease and all of those things. And then we tried to do certain simple predictable mapping or NLP techniques, etc. Right. So that's what I think we have tried to do. Then the third step is like, we try to do the content generation. That is from the scientific language to the patient language. We use a lot of generative techniques to do that stuff, which is just a little bit of more complex one. Then when we generated it, we want to establish the context so that there is an orderly information that is being generated in that patient leaflet, so that everything is in order. So first is like the name of the drug, composition of the drug, the leaflets, and then there is no duplication when it's generation. The language is very simple to be understood by even a 5th grade student, etc. So those are the certain things we try to look at, and then establish the context. So you cannot just generate it, right? So it needs to be in that particular context. You need to generate it. The semantics come into play. So these are the things that we actually did in actually building this solution, right? So from rules, designing the template, to actually building the dictionaries using basic NLP techniques, then moving to the next state of content generation, which is advanced techniques, then again semantics, context setting, which is again advanced techniques. So these are the different steps that we have employed there. So with that, I will quickly, I think since we have understood the context, and then I think we have less time, let me quickly finish in the next 2 to 3 minutes so that I can take certain questions. Okay. So if you really look at on the left-hand side, the scientific term is anaphylaxis, right? But the system has to generate the language that is there. May affect up to 1 in 10,000 people. This language has to be generated by this. And then similarly, if you really look at it, there is some Stevens-Jones syndrome. If you tell the patient, you will not understand it. So you need to explain it, serious illness with severe peeling and swelling. All of those explanations have to be provided. That's where this generation comes into picture. So the left-hand side is what the scientific, right-hand side is what we have generated. So that's what the solution outcomes looks like. So with that, I think I'll just quickly touch upon one more case study. It's a very interesting case study because automation can come in multiple forms. This is for Port of Barcelona, where you have ships coming to the port. And the port has a very large space, by the way. Today, what is happening is like there is a radar system which can detect where the ship is. Then there is something what we call as AIS system on top of the ship itself, which will send certain signals. And then through that, we will know that where the ship is located within that port, right? So all those things. So that is something which is there. But then radars, we have some blind spots where we were not able to detect where the ship is within the port. That's one of the challenge. The other thing is like the AI system, it needs a lot of configuration, and then this is not something which the port can control, etc. So the locating the ship is one of the biggest challenges in the port of Barcelona, where thousands of ships come on every single day. Because that's a problem statement. Now, what we did, we alone will not be able to solve the solution. So we have partnered with Huawei, who have actually provided some of the best cameras, which can be located at different parts in the port. And then we have also partnered with Vodafone to give that 5G network for us. So it's a very powerful 5G network, not like the 5G network that we experience in different cities in India. Okay, so that's something which we have partnered with. And then I think we have built this solution. So if you really look at what we have done, we have tried to actually look at the bow and the stem of it. So at the end of the day, we want to detect where the ship is. And then the size of the ship is. So you need to know the edge of the bow. You need to know the edge of the stem, which is the start and the back of the ship. So that is something which we want to know, right? So that's one thing we have done. I'm just rushing it up. Okay, so sorry for that. And the first step is the object detection problem. And of course, and then in object detection problem, you try to draw a lot of boxes there using the pixels and other things. So that's what you see in this chart. And sometimes these boxes overlap between two ships because the ships can stay close to each other. So we need to be differentiating between which ship to which ship. Then we need to draw a line to connect to the bow to the stern of the ship, and all of those things happen. Okay. Once that happens, the another challenges when as we did the project, it come up is like some ships are coming in night, so you need to be tweaking the models so that we can even detect ships at the night, etc. That's one of the key challenges that we have to face. The other thing is like the object detection models or the models that we develop can actually only give you the pixel size and etc. those parameters. But we need the real world coordinators, which is like the latitude and longitude, etc. So we have found another mechanism, algorithm to actually translate pixel values to the real world coordinates of the latitude and longitude. And then I think for that, we need to know the camera, where it is fitted, the focal length of the camera, the angle at which it is being positioned. So the intrinsic and extrinsic properties are being used to actually determine the latitude and longitude, right? And then all of this, once we deployed that on the edge server so that it did not come to the cloud. So we can put a server in the port, and then this application is running there. So what has happened is that this scenario where I think any ship that is coming into the port, I don't know whether you were able to see the video, moving video, you can actually detect the object detection, which you can see in the left-hand side. You can detect the size of the ship, the latitude and longitude, and then it gets registered in the system there. Okay, so this is what the outcome of the solution. This is also kind of an automation. So automation can take multiple shapes. So this is what I want to cover up in this session. But I will stop here, and then I want to take a few questions there.
Thank you for the wonderful session, sir. I'm sure many of us got to know the difference between what we are learning and how different is it to deploy the models, and how important is it to learn the difference between them. So I have a few queries from our students, sir. I'll just start reading them. One of the student has wrote, what I understood is that we are improving the model by adding operations in the pipeline, but still the source remains the same, the data. And in past, we have seen many chatbots face challenges because of wrong learning or input data. Language models are commonly termed as stochastic parrots, repeating a lot but understanding little. How do we deal with this problem?
Yes, see, the sources of the data, okay, if you're really looking at building a chatbot, we actually go and look the existing conversations, the existing chats that are available, and then we take them as the ground truth for understanding the intent. We also look at how the dialogue flow should look like and all of those things, and then that is how we build the chatbot today. But whenever the chatbot is being built, And then whenever the end user or the consumer or is going to use the chat, it is not going to serve his full purpose, the internet purpose. Either he might not go to the final step, or it will try to give you an inappropriate response. It will not understand you what you have said and all of those things. Of course, I'll not get into the models that we use today. There are like multiple models that go into it. But if you really look at that, the way that we look at it is like we try to disambiguate where in the conversation that the user is feeling, right? So we have built mechanisms to understand that if the user has come, let's say that he wants to know information about the student loan, and then this guy has actually been taken to the student loan. And once, if he has already going to the student loan, he has been given all the eligibility conditions, all the documents that he needs to give, and etc., etc., etc. All of those things have we gone to that set of logical steps that are there, that the chatbot are not. At what part are we failing? So that is where we go and try to intervene with the changes in the dialogue. Now there is another part to it. The data that we have actually initially used for training may not be sufficient, because we have built hundreds of chatbots in the last 7-8 years. At least 100 plus clients today are using that. I can very well tell that we have achieved only about 40% to 50% automation there, which means that only a maximum of 50 of the queries that are coming every day can be addressed to the chatbot. Still 50 are going to be there. What we do is, like, for the failed conversations, we collect that data. We try to go and tweak the intent models. We go and tweak the dialogue flows. We go and tweak the underlying understanding models, etc. So that is what we do to improve the performance of the chatbots.
Sir, I have a couple of doubts myself. One of them is regarding the explainability of AI. As you said, humans and AI-powered systems work hand in hand to bring the best output. But once I know there's a lot of research going on in explainability in AI, but once the AI systems reach, can the AI systems reach a level where the models like loan approval or application approval models can reach a level of explainability where there's no human supervision required to give the final decision?
Yes. Okay. So let me give a live example to that. Right. When we were working with one of the large insurance clients in Peru, which is in Latin America, where it's a very big insurer in that area. So this question came up whether at what point we should rely just on AI and then just allow the AI to take a decision, right? So we process a lot of claims for the millions of claims in a year for them. So what we have decided is, like, there are certain claims which are like low value claims, less than $25, right? So which is there. So what we told them is, like, we actually automate those claims. Okay, there is no human intervention in those claims, right? So even if the human has objected to it, we go and pay out to them. Okay, so that's the kind of one area. The second space is, like, we provide the explainability to the users, but then that explainability should be made available to the decision maker so that he reads it and then he clicks the button. Still, that judgment still goes to the thing, but the time that he needs to make the decision has actually gradually reduced from 45 minutes to 36 minutes. So that is the kind of a productivity or efficiency that we could bring in that. But still, we allowed the decision to be made. But then in that conversation also, we decided that after 3 years, if the system is in place, and I can tell that with 99% confidence, the system has been made to take the decision, then I can go and automate it, right, at that point of time. So that is how I think at the level approach that we take in terms of explaining.
Also, the benchmark of when we can give the power to the human can be also dependent on the value of the user that it's.
Yes, yes.
One more doubt I had was regarding the trust of AI systems. One of the AI systems you have explained about is related to the pharma industry, where they're converting the document to a human understandable level. But that is an industry where even the slightest of one word errors can make lots of difference in the whole document altogether. So is it worth it to automate the process?
Yeah. Okay. So that's a very valid question, right? That's a very valid question. I think in this whole process, right? When I said 20,000 people, there are 18,000 people who are actually do the first level of conversion. Then there are 2,000 people who are validating it. So we are looking at automating those 18,000 people who are actually doing this work, but still a final validation is being done there. We want to reduce from 20,000 not to 0, but we want to reduce from 20,000 to 18,000. That's our objective.
That's still a huge win for product.
Yes, exactly.
One of the user has asked me, how do we take feedback from user once the model is deployed? Is the sorry, sir. In the question, did this answer your question that we get after using the chatbot part of it? But that's again is just a yes or no question. How do we get insight from the data?
Okay. So I got what the what is asking. Okay. So did you get did you get did this answer your question, right? See, did you answer this question yes or no, right? If the user says yes, it did answer my question, the prior step, whatever that has been done, which means that has been executed successfully. So that is how I read that chat conversation, right? So for example, I have the consumer has asked for, customer has asked for something, I have given a response, and then after the response, we ask a question, did this answer your question? If they say that it is yes, then I think I tend to assume that the earlier answer that is being provided is the correct answer, and then that I use it as a positive feedback. But then they may say no. Okay, at that point of time, it could be possible that you may have erred in multiple steps in this. That is where I think a deeper dig of the things is required. So we have built a solution, what we call it as a conversational insight solution. I don't have the time to explain it, where we look at each node in the conversation of the chatbot, and at each node, what are the different paths from that node one can actually take it. And then actually evaluate, like say, what are we go one step prior to that node and then see that whether the error has occurred there, and then that has led to this kind of thing, right? You can think of like a Markow's chain modeling or other things where root cause effect kind of an analysis that is being done there to understand where the problem is, to understand the next course of action. And some of the things could be subjective answers. So, but somebody has to manually look at those subjective things and then actually translate into the data that can be consumed by the model. That is also a fair chance to answer that question.
Thank you, sir. That's it for the queries. I'm sure I'm thanking on behalf of all the students when I say how important this session was. The true lesson we learned today was, irrespective of how much accurate or how big a model you build, it's important to bring value out of the model. And the better value you bring, the better use it can get. So we on behalf of IIT Madras, thank you for giving this session, and I thank IITM team and NPR team for giving this session. Thank you.
Thank you very much. Thank you for all your time. Thank you. Bye bye.